When the Solar and Heliospheric Observatory SOHO transmitted its raw feed from October 2010, analysts immediately noticed a gap, a single blank frame. On its own, it might have meant nothing. Solar interference, packet loss, a glitch in compression. But this wasn't just any frame. It was the perihelion moment, the exact timestamp when 3Gen Atlas passed 0.31 astronomical units from the Sun, the closest point in its entire trajectory. At first, mission engineers brushed it aside. Missing frames happen all the time. Cosmic rays, overexposure, even telemetry desynchronization can wipe data clean. Yet, as other observatories uploaded their own recordings, ESA's Solar Orbiter, NASA's Parker Probe, Japan's Himawari network, the same blank gap appeared again and again. Each observatory had lost the same 30-8 seconds of visual data, the same timestamp, the same absence. That is not coincidence. When analysts at the European Space Agency began to align the feeds, they discovered that all systems, despite operating on independent clocks, had gone blind at 1420 Gen 6, 0 Gen 4 UTC. For exactly 30 Gen 8.2 seconds, there was nothing, no light, no transmission, no telemetry. Then, as if nothing had happened, the object reappeared, but in a subtly different place. The trajectory plot didn't match pre-Gen perihelion predictions. 3Gen Atlas was slightly off course, less than 1/10 of a degree, but enough to catch attention. The orbital curve calculated days earlier suggested a clean exit. Instead, it emerged with an altered vector, as though something had nudged it mid-Gen pass. This is where the problem begins, because at that proximity to the Sun, only two things could alter a comet's course: asymmetric outgassing or an external force. And yet thermal models of 3Gen Atlas predict minimal jet activity during perihelion. The heat was simply too intense for volatile Zen-driven thrust to survive that long. The outgassing, if any, should have been chaotic, not precise enough to produce such a neat deflection. And so the question formed, what could cause every observatory to go blind for the same 30 8 seconds, and then resume recording an object slightly off its predicted path? To understand the significance of that absence, you have to know how tightly these systems are synchronized. SOHO transmits data continuously, capturing frames every 12 seconds. Redundancy systems overlap with the Parker Solar Probe and Solar Orbiter. If one instrument fails, another fills the gap. It is designed that way. That is why a simultaneous blackout across all three is nearly impossible, unless the blackout was intentional or caused by something external, like a burst of electromagnetic interference. Normally such an event would show up in the magnetometer logs, but no spike appeared. Solar wind remained stable. The background radiation was constant. No flare, no coronal ejection. The Sun was quiet. So what caused it? Some within the network proposed an internal synchronization fault. Others quietly pointed to something else, a temporary signal override, a data jam, as if for those 30 8 seconds, all instruments had been blinded by something between themselves and the Sun, something close enough and deliberate enough to mask its own appearance. In other words, 3Gen Atlas might not have been just passing by the Sun. It might have been doing something while we couldn't see. At the same moment the visual feeds dropped, several radio telescopes, including the Allen Telescope Array in California, logged a brief high-Zen frequency spike at 2.29 GHz. It lasted less than 2 seconds, but was detected on multiple antennas. The source direction near the solar limb consistent with 3Gen Atlas's position. It was later dismissed as cross-Jan channel bleed from a terrestrial satellite. But when analysts retraced orbital alignments, no active satellite matched that vector at that time. Whatever the signal was, it originated near perihelion. That is when people began examining the missing frame with new eyes. Not as a failure, but as a mask. If 3Gen Atlas emitted or reflected a burst of energy strong enough to saturate detectors, it could easily knock multiple instruments offline. The system would interpret it as noise and discard the frame. But it wasn't random. The timing was too perfect, the blackout too complete, the return too smooth, like something that wanted to be unseen, just long enough to do what it needed to do. When the feeds came back online, the first visible frame showed the object elongated, not spherical, but stretched, as though part of it had expanded or rotated during the blackout. The brightness pattern had changed too. Before perihelion, the coma had been uneven, flaring to one side. Afterward, it was symmetrical. The reflectivity had doubled. That is not how dust behaves after solar heating. That is how a surface behaves after shedding a layer. Astrophysicist Jean-Marie Lafon from the Paris Observatory called it a structural transition. He compared it to the way spacecraft deploy radiators after a high Zen energy burn. His words were careful, technical, but the subtext was unmistakable. 3D's NI Atlas looked like it had done something mechanical while we weren't looking. NASA refused to comment. ESA released a brief note calling the loss an expected data anomaly due to high Dan intensity light interference. Yet internal correspondence leaked 2 days later told another story. In one email, an engineer wrote, "We didn't just lose the frame, we lost synchronization across all nodes. It is as if something commanded them to go dark." That line was quickly redacted from subsequent releases. If you chart the object's brightness curve, the data paints an eerie picture. Just before the blackout, brightness increases exponentially, about 0.7 magnitudes per minute, then total silence. When it resumes, the brightness drops by half, but spectral readings show more metallic reflection. Less gas, more solid surface reflection. That shouldn't happen in a natural comet. When gas vents, brightness spikes. When it stops, reflectivity falls. Here, it did the opposite. One possible explanation: a surface layer of volatile material burned off completely, revealing something underneath. Smoother, harder, and more reflective, possibly metallic, possibly structured. It is not proof of anything artificial, but it is a deviation so clean it doesn't fit with random fracturing or ice sublimation. In every known case, fragmentation after perihelion creates chaos. Uneven brightness, diffuse plumes, dust tails scattering unpredictably. 3D's NI Atlas did the opposite. It became more stable, more compact, more geometrically coherent, as if the heat didn't destroy it. It triggered it. Astronomers are cautious by nature. They avoid sensational conclusions. But this case presents a unique problem. The missing frame is not absence. It is presence disguised as nothing. It is a measurable, structured void. The same duration across independent observatories with synchronized recovery and altered telemetry afterward. When confronted with these coincidences, you can only stack them so high before the weight tips the balance. Either the universe pulled off an incredible series of random technical glitches, or something intentional occurred at perihelion. The data gap is not the anomaly, the precision is. And yet there is still one unanswered question. If the blackout was caused by the object itself, what mechanism could produce that kind of interference without any detectable energy surge? Some researchers suggest magnetic shielding. Others propose an electromagnetic pulse caused by sudden solar interaction. But one idea keeps resurfacing, an idea that sits uncomfortably between science and speculation. That the missing frame wasn't an accident, it was a cover, the moment something activated. When the data was reviewed later, subtle alignment shifts appeared. A change in the orientation of its jets, the angle of its tail, even the core spin, as if 3D's NI Atlas had adjusted itself in those 30 seconds. Whatever happened, it left behind patterns that defy coincidence. And it is those patterns, subtle, mechanical, deliberate, that lead directly to the next anomaly. Because right after the missing frame, something else emerged in the data. Not darkness this time, but heat. When the data feeds returned after the blackout, the first thing analysts noticed wasn't visual. It was thermal. Instruments across multiple observatories recorded a sharp, instantaneous spike in temperature during the precise window when 3D's NI Atlas vanished behind the solar glare. The readings didn't match any known model of cometary heating. For a brief period, the object's thermal profile exceeded what carbon-based compounds could withstand. It wasn't sublimation, it was something else entirely. The Parker Solar Probe registered an anomaly first. Its particle sensors detected an unexpected surge of infrared radiation centered around the exact coordinates of 3D's NI Atlas. The spike lasted under 2 minutes. Yet the thermal rise was extreme, almost as if the object reflected sunlight directly back toward the sensors instead of absorbing it. Normally a comet at perihelion is a frenzy of vaporizing ice, shedding mass chaotically as solar heat boils its surface. But the heat signatures here were clean, sharp, directional. It looked more like a mirror flashing light than a dusty nucleus reacting to solar energy. ESA's solar orbiter picked it up next. Its SPICE spectrometer logged spectral lines inconsistent with the standard ice and dust composition. The thermal gradient peaked at over 1700 Kelvin, well beyond the tolerance of organic compounds and typical silicates. At that temperature, any volatile substance should have vaporized completely, leaving nothing behind but dust. Yet 3D's NI Atlas emerged intact, its coma shrinking rather than expanding. That single fact contradicted everything we know about comet behavior near the sun. The closer they get, the more they disintegrate. 3D's NI Atlas, however, did the opposite. It became denser, more cohesive, The thermal spike didn't just surprise observers, it confused their instruments. Radiometric sensors briefly reported negative values, as if heat had been absorbed faster than the sun could supply it. Some at NASA's Goddard Space Flight Center suggested this was due to an uncalibrated gain shift, but a few others quietly pointed to something more peculiar. A possibility that 3Deni Atlas might have briefly emitted or redirected heat in a controlled pattern. That hypothesis wasn't published. It was mentioned in an internal note never meant for public eyes, where one engineer wrote, "If this was natural, it is the most efficient radiator ever observed." As the solar orbiter's readings poured in, scientists began mapping the thermal profile frame by frame. What emerged was disturbing symmetry. The heating was not distributed randomly across the surface. It concentrated along a band wrapping around the equator of the object as if encircling it. The band brightened sharply, emitted an intense infrared flare, then vanished entirely. Afterward, 3Deni Atlas's surface reflectivity increased, suggesting that whatever burned or vaporized in that belt left a cleaner, more uniform material beneath it. It was as though a layer had been deliberately stripped away. At first, the event looked like a phase transition, a natural metamorphosis under extreme heat. But even then, comets don't reorganize themselves in such an orderly fashion. Ice doesn't sublimate in perfect rings. The probability of spontaneous symmetry is effectively zero. This left researchers with a troubling choice: either accept a coincidence of cosmic precision or entertain the idea that something in or around the object was responding actively to the solar environment. Independent analysts tried to reconstruct what could produce such thermal coherence. Some theorized it was a phenomenon known as differential albedo reflection, highly reflective patches alternating with dark material creating feedback loops of heat. Others, less convinced, speculated that if 3Deni Atlas contained metallic compounds, the reflection could create localized heating zones capable of mimicking control. But the problem with both ideas is time. The thermal cycle was too fast. It initiated, peaked, and cooled in under 90 seconds. That is shorter than the reaction time of any known natural feedback mechanism. Something accelerated the process. The oddest part was how silent it was. The Parker probe's plasma detectors expected a blast of ionized particles during such a temperature surge. There was none, no outgassing, no plasma arc. The object's surrounding space remained eerily calm. In a natural scenario, the heat would rip volatile gases free, creating turbulence. Here, the opposite happened. Temperature up, motion down, energy without chaos. It was then that the data from Earth-gen-based observatories arrived. The Mauna Kea telescope in Hawaii and the Atacama facility in Chile, both observing in near-gen infrared, reported identical findings. A brief pulse of heat matching the same coordinates and timestamp. That synchronization across thousands of kilometers is virtually impossible to fake. Something real emitted or redirected that energy. And yet, when the light returned to normal, the comet's trajectory showed a minute deceleration, as though part of its motion had been countered, slowed, or redirected. Heat and deceleration in tandem in rocketry. That combination is familiar. It is called thermal braking. Most scientists refuse to entertain that comparison publicly, but in back channels, the term appeared repeatedly. Thermal braking implies intent, using heat to alter momentum, and though it is tempting to dismiss as science fiction, the math doesn't lie. A concentrated burst of energy along one axis could produce a measurable adjustment in velocity, even in a small body. The trajectory data suggests exactly that. A minute change consistent with thrust, too subtle for a natural explosion, too sustained for random outgassing. To grasp how unusual that is, consider the solar radiation pressure acting on any body near the sun. The closer an object approaches, the stronger the force, but it is always repulsive, pushing outward. Yet, after Perihelion, 3Deni Atlas's deceleration implied resistance. As though it were pushing against that force. There is no mechanism in nature known to reverse radiation pressure. None, unless the object somehow reflected light in a non-anisotropic way, directing its output like a sail adjusting its angle to the wind. If that happened, it would explain both the heat spike and the change in velocity. But that introduces an even stranger implication: control of orientation. Astronomers at Caltech compared the polarization vectors from before and after the event. The orientation of 3Deni Atlas shifted by about 12 degrees. That doesn't sound like much, but for an interstellar object under no known torque, it is enormous. The direction of maximum reflection changed, aligning exactly with the solar vector, like something adjusting to face the source of heat rather than flee it. Still, most agencies stayed quiet. Official reports described unusual solar scattering behavior. A few astrophysicists hinted privately that it resembled a specular reflection pattern, the kind you'd see on smooth metallic surfaces, but calling something metallic in an interstellar context opens a door few are willing to walk through. Within 24 hours, online speculation exploded. Forums began comparing the readings to those of Oumuamua, the first known interstellar visitor detected in 2017. That object too had shown unexplained acceleration without outgassing, prompting years of debate. But 3Deni Atlas was different. It wasn't accelerating, it was stabilizing. Where Oumuamua tumbled unpredictably, this object seemed to correct itself like a system maintaining equilibrium. Natural fragments don't do that. Artificial ones might. The thermographic data continued to circulate quietly among international teams. Several independent research groups attempted to simulate the event using comet models. None reproduced the spike's shape or symmetry. The only way to approximate it was to assume that the surface material changed reflectivity mid-Zen event from dark to mirrored Zen bright within seconds. That is not erosion. That is transformation. Some called it coating loss. Others used a more charged word, shedding, because if the outer layer was indeed volatile, its complete removal at perihelion could have been intentional, a designed reaction to solar proximity, a way to protect what lies beneath. In that sense, the temperature spike wasn't a problem at all. It was a function. The silence surrounding the event grew heavier with each day. Agencies stopped publishing real Zen time updates. The solar orbiter's temperature telemetry was suddenly under review. Parker's data pipeline was paused for recalibration, but by then private networks had already archived the numbers. The spike happened. The heat was real, and whatever its cause, it wasn't random. Every pattern observed since then traces back to that singular moment. The flash that wasn't supposed to exist, the temperature that shouldn't have risen, and the stability that shouldn't have followed. It is the kind of signature that forces you to choose between two explanations. Either nature found a new way to organize matter under extreme heat, or 3Deni Atlas did exactly what it was built to do. And just as the world began to debate the meaning of that heat, another anomaly appeared. In the frames following the spike, a new jet of material emerged. Not chaotic, but perfectly linear, pointing away from the sun. It didn't spray like a vent. It aligned like a thruster. That is where the next question begins, because if that jet was real, then for the first time, 3Deni Atlas wasn't just reacting to the sun. It was responding. When the first post-Gen perihelion images of 3Deni Atlas were analyzed, the discussion about heat quickly gave way to something even more unsettling: the jets. Every comet vents gas and dust when it nears the sun. Those jets are chaotic, uneven, and unpredictable, like geysers firing at random angles, each shaped by cracks, fractures, and buried ices. But the images from late October didn't show chaos. They showed precision. In the sequence taken by ESA's solar orbiter between 1420 Gen 8 and 1440 Gen 1 UTC, a thin, bright plume extended cleanly from one point on the object's surface directly away from the sun. Its axis remained perfectly straight for several minutes, holding steady as the object rotated. Normally, a comet spin would cause plumes to sweep, bend, or scatter. Instead, this one stayed locked, like a stabilizing jet maintaining orientation. At first, teams assumed an alignment artifact, a trick of perspective, but further analysis showed the jet's direction was constant relative to solar north, not the camera angle. That meant it wasn't an optical illusion. It was real, and it was deliberate in its geometry. The plume wasn't diffusing into space like typical gas. It was collimated, narrow, focused, as though shaped by confinement. This was when the comparison to known comet activity broke down entirely. Standard comet jets expand at about 20 to 200 meters per second, dispersing rapidly as they leave the surface, but the brightness profile of this one suggested acceleration. The further it extended, the more uniform its intensity became, like a stream maintaining cohesion. One astrophysicist in Madrid compared it to an ion exhaust. The phrase didn't appear in the final report, but it circulated quietly among data analysts. The physics didn't match outgassing. To sustain a linear jet under that kind of solar pressure, the material would have to be ejected with precision, as if through a nozzle. Some scientists proposed that the jet was the result of an unusually deep fracture channeling volatiles in one direction, but even that explanation required a degree of structural order that seemed improbable for a natural body battered by heat. Then came the timing issue. The jet activated within seconds after the thermal spike, the very same window that produced the missing frame. That synchronization wasn't lost on anyone. A heat event followed by directional ejection, cause and effect, one event leading to motion. If it were a natural process, the odds of both phenomena aligning that cleanly would be astronomical. NASA's Jet Propulsion Laboratory (JPL) simulated various venting models to see if sublimation alone could replicate the pattern. None fit. Gas should spread unevenly. Tail curvature should appear within minutes, and the jet's brightness should decay exponentially. Instead, 3Ni Atlas's emission stayed constant for nearly 11 minutes, then stopped abruptly. The cutoff was too sharp to be random. It was like a switch had been flipped. To some observers, this was the point where curiosity turned to discomfort. The object wasn't behaving like a fragment of ice and rock reacting passively to sunlight. It was performing a sequence, a thermal flash, a straight jet, a trajectory correction, each phase following the previous one as if scripted. When the Parker Solar Probe's field sensors were cross-gen referenced with the timing of the event, another pattern emerged. During the jet emission, a faint magnetic pulse was detected, localized and transient, centered at the object's coordinates. The signal wasn't strong enough to indicate an electrical discharge, but it hinted at electromagnetic interaction. Natural gas plumes don't produce that kind of signal. Metallic ions might. If the material vented was ionized metal vapor, say nickel or ions in carbon compounds, it would explain both the reflectivity increase and the collimation. Ionized particles can be shaped by electromagnetic fields, but that leads to a more difficult question. What created the field? A few researchers proposed an induced magnetic sheath formed as the object interacted with solar plasma. That is plausible, but still doesn't account for the precision or directionality. Others whispered about the possibility that 3Ni Atlas's internal composition wasn't random, that it contained conductive veins or structures capable of guiding emissions. Those ideas never made it into official statements. They lived in encrypted group chats between astrophysicists who didn't want to risk their credibility. Meanwhile, the public data feed remained silent. ESA's published thermal and spectrographic readings skipped over the relevant minutes entirely. The explanation given was data corruption due to high dynamic range, but the timing was too specific. Every missing data packet corresponded precisely to the jet event. It began to look less like corruption and more like emission. The one independent source that managed to capture partial imagery was the Solar Terrestrial Relations Observatory, StereoDNA. Its coronagraph recorded a faint trace of the jet in ultraviolet light. The spectral analysis later showed an emission peak inconsistent with water vapor or carbon dioxide. It aligned more closely with ionized nickel, a rare signature, but one that had already appeared in previous spectroscopic readings weeks earlier. That consistency was troubling. Nickel shouldn't exist in such quantities unless 3Ni Atlas carried heavy metal compounds inside, and those compounds shouldn't vaporize in such an ordered way. It hinted at layers, not random mixing, but stratified structure, as if the object had been built, not born. The timing, direction, and spectral composition together painted a picture too coherent to dismiss. Something about the perihelion passage had activated a reaction that looked coordinated, and that reaction produced thrust. A small one, yes, but measurable, after the jet event. Orbital calculations showed a subtle yet definite deviation from the predicted escape trajectory. The object's outbound path shifted by about 0.03 degrees. That is enough to change its long-term destination by millions of kilometers. What is more, the jet pointed opposite that deviation, exactly as if compensating for solar momentum. It wasn't drifting randomly into a new path. It was steering. By the evening of October 30th, several private astronomers began voicing what institutional scientists wouldn't, that the data resembled propulsion, not in a cinematic sense. Not flames or engines, but something simpler, thermally induced vector control, the kind of maneuver you'd expect from an automated probe adjusting course through natural forces using nothing but light and gas. If that idea sounds far-fetched, it is worth remembering how 3Ni Atlas entered the system in the first place. Its inbound path was already bizarre, hyperbolic, retrograde, and unnervingly precise. Its alignment with the ecliptic plane was within a margin too small to be random, and now, during perihelion, it seemed to be demonstrating control, the one thing no natural body should have. But here is where the story deepens. Just after the jet ceased, the object's spin changed. Its rotational axis shifted, but not because of impact or breakup. It realigned itself slightly, smoothly, toward the same vector as the jet had pointed. That is not coincidence, that is adjustment. For those studying the event in real time, it was like watching something wake up. It had withstood the sun's heat, shed an outer layer, released a controlled burst, and then stabilized, not destruction, activation. The implications were staggering, yet no one could say it publicly. Too many reputations, too much protocol. Agencies defaulted to technical language, non-Zen gravitational perturbations, post-Zen perihelion venting, thermal outgassing symmetry, phrases designed to explain without admitting. But behind the language, the unease was spreading, because if the jets weren't random, if the heat wasn't spontaneous, and if the missing frame wasn't coincidence, then 3Zen Atlas wasn't just reflecting sunlight, it was responding to it. And as the object began to move outward from the sun, another signal anomaly appeared. This time, not visual but radio. For a few minutes, every telescope tuned to the object's coordinates fell silent. Not interference, not static, just absence. A perfect calculated silence that arrived exactly when the jet disappeared. That is what led scientists to the next question, the one that changed everything. The first reports of the radio blackout came quietly, buried in telemetry summaries that most analysts would have ignored. It began as a faint disturbance across deep space monitoring arrays, a brief flicker in the signaled Zen-to-Zen noise ratio that seemed to coincide with the end of the jet event. Then, without warning, the line went flat. No static, no distortion, just nothing. A band of pure silence cutting through the spectrum like a knife. The phenomenon lasted barely 90 seconds, but it didn't just affect one instrument. It hit across the board. The Allen Telescope Array in California, Jodrell Bank in the UK, and the FAST Observatory in China all reported identical drops, a total collapse in the signal from 3Zen Atlas's direction. Normally, when something goes quiet in deep space frequencies, you still hear the background. Solar wind hiss, cosmic microwave fuzz, electromagnetic clutter. But this wasn't that. It was as if a small section of the universe had gone mute. What startled the teams wasn't only the suddenness, but the precision. The blackout aligned perfectly with the object's coordinates. The rest of the sky remained normal. Every frequency outside the 2.2 to 2.4 GHz range behaved as expected. Only that narrow band, one often used for deep space communications, had gone dark, and it came back just as sharply as it vanished, like a switch flipped twice. Engineers at JPL initially assumed a solar burst. The sun can easily overwhelm receivers during perihelion events. But the Solar Dynamics Observatory saw no flare, no coronal mass ejection, no spike in solar radio output. The sun had been calm. The blackout wasn't coming from it, it was coming from near the object itself. When ESA cross-Jan referenced timestamps from the solar orbiter and Parker probe, something even more unnerving emerged. Both spacecraft logged subtle fluctuations in ambient electromagnetic fields at the exact same moment. The readings weren't high enough to trigger alarms, but they showed a consistent pattern, a drop in baseline noise followed by perfect stillness. Instruments designed to hear chaos were suddenly deaf to it. Then, just as the silence reached its deepest point, 3Zen Atlas's reflective signature shifted again. Its albedo dropped as if its surface had darkened. In the same instant, the radio silence ended. It is rare for astrophysicists to call anything impossible, but the combination of events bordered on that. A controlled thermal spike, a directional jet, and now a synchronized communication blackout. Random natural phenomena don't stack that neatly. Yet the more evidence accumulated, the more official channels retreated into vagueness. NASA referred to the radio drop as temporary interference from plasma scattering. The European Space Agency used the phrase signal saturation event. Neither matched the data. There was no saturation. There was nothing at all. The strangest aspect wasn't what was lost, but what filled the void when the signal returned. During post-Jan event analysis, astronomers noticed faint rhythmic fluctuations embedded in the noise floor, too structured to be natural, too weak to classify as data. The intervals repeated at 0.187 seconds, roughly 5.3 Hz, not random, not harmonic, just steady, like a heartbeat buried under static. Independent observers from the SETI Institute picked up traces of the same pattern, but hesitated to interpret it. Cosmic signals can imitate rhythm through coincidence, and most turn out to be instrumentation echoes. But this one had one key difference. It appeared only in the exact window after the silence lifted, and it repeated across multiple observatories, separated by continents. Even accounting for atmospheric distortion, the synchronization was uncanny. If this was interference, it was coordinated, and if it wasn't interference, it was something else. At this point, most data teams were already stretched thin. The observatories were receiving more attention than ever, not just from scientists, but from intelligence agencies monitoring the situation. Requests for raw telemetry skyrocketed. Private research networks found their access quietly revoked. Certain data channels went offline for maintenance. The timing was again remarkable. Inside those networks, analysts began whispering about an uncomfortable hypothesis. That 3Zi atlas had emitted something during perihelion. A pulse, a transmission, or an electromagnetic response triggered by the sun's energy. Not a message in any recognizable sense, but an action, a deliberate silence followed by a signal. The kind of pattern you'd expect from a device protecting itself from overload, then rebooting. The theory found an unlikely supporter at the Beijing Astronomical Observatory. Dr. Wei Han, a plasma physicist, noted that the silent band coincided with a rapid drop in ion density near the sun's limb. That, he suggested, could only happen if an external electromagnetic field momentarily disrupted local plasma. In other words, something created a bubble of quiet, a zone where charged particles couldn't interact. He called it a radio shadow. Others called it a shield. When this finding leaked, it reignited the same debate that surrounded Oumuamua 8 years earlier. Back then, unexplained acceleration was the mystery. Now, it was absence. Absence of heat, of light, of sound, an intentional quietness. But there was one key distinction. 3Zi atlas wasn't just passing through the solar system. It was reacting to it step by step in real time. To test whether the silence might have been caused by Earth-Jan-based interference, teams cross-Jan-checked data from the Mars Reconnaissance Orbiter, which had been observing the sun's far side during the event, even from Mars vantage. The blackout registered faintly in the signal logs that ruled out any local cause. Whatever happened, it was happening near the object itself. When the silence ended, something else shifted. The object's spin rate, constant for weeks, suddenly slowed by a measurable fraction. It wasn't much less than 0.02 rotations per hour, but it was precise. Consistent across every instrument. Some suggested the loss of angular momentum resulted from outgassing, but there was no corresponding material emission, no debris, no plume. The object had simply changed its behavior as the silence broke. The silence then wasn't just a gap in data, it was a turning point, a before and after, before the blackout. 3Zi atlas was active, flaring, ejecting material. After it, the object became cold, dark, reflective, a mirror drifting outward in eerie stability, as if something inside it had completed a process and powered down. In the days that followed, the frequencies around 2.3 GHz showed faint periodic ripples, weak, almost subliminal, repeating every few hours. Some speculated they were residual solar echoes. Others thought they were telemetry. None could explain why the ripples decayed at the exact rate of the object's outbound velocity, as if trailing behind it, like a signal fading with distance, officially. No agency acknowledged the silence. The incident vanished from press briefings, replaced by generalized comments about routine anomalies. But in the archive datasets, the silence remains. A perfect, inexplicable void surrounded by noise. The kind of absence that feels engineered, not accidental. And when investigators tried to trace its boundaries, they discovered something even stranger. The silence wasn't perfectly horizontal on the spectrograph. It curved slightly following the object's trajectory, as if anchored to it, a band of quiet, moving with 3Zi atlas as it turned away from the sun. That shape gave the event its name, the silent band. It wasn't just a momentary blackout, it was an orbiting shell of silence traveling with the object like a cloak. For hours after the event, receivers pointed directly at it heard less than they should have. Not interference, but suppression. A deliberate muting of space itself. Whatever caused that quiet wasn't finished, because within days new data from ground-based telescopes revealed a second anomaly. One buried not in sound or heat, but in light. Something in the way 3Zi atlas reflected sunlight had changed. Its polarization signature, once stable, was now inverted. The kind of reading that suggests a surface structured, not scattered. And that led scientists to the next question in this widening chain of impossibilities. By the time the silence lifted, most observatories had already shifted their attention from sound to light. The event had left behind not only confusion but an unmistakable change in how 3Zi atlas interacted with sunlight. The brightness curve was steady. Yes, but the polarization readings told a different story. They had flipped. Polarization, at its simplest, measures the orientation of light waves as they scatter off a surface. In comets, that orientation is well understood. Sunlight hits dust and gas. The particles scatter it at predictable angles and you get a positive polarization signature. But after perihelion, 3Dni Atlas began exhibiting the opposite negative polarization. Instead of diffused light from chaotic dust, the reading suggested light reflecting off a coherent, possibly smooth surface, the kind that behaves less like dust and more like a mirror. When this first appeared in the data, many dismissed it as calibration error. Instruments positioned close to the sun often struggle with glare and signal interference. But then it appeared again and again. Independent observatories from Mauna Kea, Atacama, and Tenerife all reported the same thing. An inversion in the polarization angle occurring simultaneously across multiple wavelengths. That kind of cross-DAN verification doesn't happen by accident. The effect was subtle but unmistakable. Before perihelion, the reflected light was scattered in all directions like the shimmer of powdered ice. After, it became focused, clean, linear directional. The polarization angle aligned perfectly with the object's new trajectory, not its rotation. That single fact sent a quiet chill through every analyst who saw it because in physical terms it meant the reflecting surface had changed, possibly reorganized. There are only a few known processes that can cause negative polarization in a comet. One is the formation of metallic frost, a thin reflective coating, forming as gases condense in a vacuum. But that requires cooling. Here, the change happened immediately after heating. Another possibility is microjan structuring, a surface textured with repeating ridges or patterns that polarize light coherently. That is seen in lab materials, not in space debris. As the data accumulated, the pattern grew clearer. The inversion wasn't uniform. It fluctuated every few minutes in a rhythm that seemed to match the object's new rotational period. In other words, parts of the surface reflected light differently as it turned, like alternating panels of distinct material. That is not something you get from fractured rock, that is a signature of design. Still, no one dared to say it outright. Official reports described the anomaly in neutral language, a complex photometric behavior consistent with fine surface evolution, but behind closed doors the language was less guarded. One researcher from the European Southern Observatory reportedly called it structured reflectivity. Another from the University of Tokyo wrote in a private memo, "This is no longer a diffuse body. It is behaving like an engineered surface." To understand how shocking that statement was, you need to realize how stable polarization patterns are in natural objects. Even when comets disintegrate, their scattering angles remain positive. The particles may disperse, but their optical behavior stays chaotic. A clean inversion like this, once sustained over hours, implies that something unified the surface, smoothed it, possibly even realigned it. When the solar polarimeter from the National Astronomical Observatory of Japan analyzed the raw spectra, it found faint harmonics, secondary peaks in the polarized light consistent with interference patterns. These are microscopic resonances created when waves reflect off surfaces separated by consistent distances. It is the same effect used to measure thin films or layered materials in laboratories. On Earth, that is called coherent backscatter. In space, it usually means structured layers, alternating densities or reflective coatings. 3Dni Atlas displayed it in near perfection. The interpretation was unsettling but unavoidable. The object had either developed or revealed a stratified surface, alternating layers that could manipulate light intentionally. The data looked less like a random aggregate of dust and ice, and more like a shell, a casing. There is another detail almost buried in the early polarization graphs. The angle of reflected light didn't just invert, it stabilized, locking to a specific alignment relative to the ecliptic plane. That plane is the invisible disk on which the planets orbit. The odds of a random object matching its reflective axis to that geometry are infinitesimal. Yet 3Dni Atlas did it precisely within less than a degree. For astrophysicists accustomed to randomness, precision like this is the loudest kind of signal. Nature doesn't favor symmetry unless forced to. The first to publicly hint at the anomaly was Dr. Yelena Barash, a Russian astrophysicist known for her work on interstellar dust polarization. In an online preprint later removed, she wrote, "The polarization inversion of 3Dni Atlas is of such magnitude and coherence that a natural explanation is mathematically possible, but statistically absurd." Her paper vanished within a day. No retraction notice, no archive copy, but the phrase "statistically absurd" began circulating quietly among the International Observatory Network. By then, smaller observatories began to notice something else. Polarization fluctuations that didn't match the rotation speed, micro-Dan oscillations irregular but rhythmic, as though something within the object were modulating reflectivity in pulses. The frequency was low, about 1 every 4 minutes, but consistent, almost like a beat. Could it be an instrumental echo possibly? But the pattern appeared in 3 independent instruments separated by thousands of kilometers. Coincidence doesn't repeat across hemispheres. The modulation wasn't strong enough to imply emission. It didn't transmit. It reflected like a mirror, changing how much light it returned ever so slightly in a controlled rhythm. It didn't carry data, not in the conventional sense, but it carried structure. By early November, the cumulative data from polarimetry, thermal readings, and radiometric analysis painted a coherent narrative, one that no institution wanted to write down. During perihelion, 3Dni Atlas had undergone a transformation. A shedding of material, a thermal spike, a directional jet, and a radio silence. Afterward, it re-emerged darker, smoother, and more reflective. Its light no longer scattered. It polarized, its signals no longer emitted. They synchronized. The phenomenon wasn't explosion or erosion, it was adaptation. Some called it coincidence stacked upon coincidence. Others saw it for what it appeared to be, a sequence, something intentional unfolding step by step. Each event preparing for the next. The missing frame, the heat, the jet, the silence, and now the light. All part of a chain. But as one researcher noted, if it is a sequence, then it must have an end. The logical next question was, what happens after the surface stabilizes? What does it reveal? That question would soon be answered, not in light or heat this time, but in gas. Because the moment polarization reading steadied, another contradiction emerged, one buried in chemistry. The carbon dioxide levels around 3Dni Atlas didn't rise with the heat as expected. They fell, and that discovery opened a new line of investigation, one that broke every known model of cometary behavior. When the spectral data from the post-jam perihelion period began streaming in, the first thing scientists expected to see was a surge in volatile gases, especially carbon dioxide. Every known comet follows that rule. As they approach the sun, their frozen interiors vaporize, releasing plumes of sun, oil and water vapor into space. The ratio is predictable, almost mathematical, but 3Dni Atlas didn't follow the rule. The moment its temperature peaked, its CO emissions collapsed. The anomaly was first flagged by a team at NASA's Infrared Telescope facility in Hawaii. They noticed that between October 28th and October 30th, the usual 4.26 micron spectral band, the signature wavelength for carbon dioxide, dropped by more than 60%. That kind of decline shouldn't happen anywhere near the sun. At perihelion, gases should erupt in violent abundance. Instead, the lines flattened, fading almost to background levels. At first, they blamed instrument contamination. The solar glare can flood spectrometers with noise, washing out faint gas lines. But cross-gen referencing with data from the Subaru telescope and the Atacama Large Millimeter Array confirmed the same thing. All depletion, precise and synchronized. Other volatiles like carbon monoxide and methane barely changed. Only carbon dioxide, the most stable, most abundant ice on a comet's surface had vanished. That left 2 explanations. Either the carbon dioxide was somehow consumed faster than it could escape, or it was never there to begin with. Both options defied the earlier readings, which clearly showed a CO-rich composition weeks before perihelion. Somewhere between inbound trajectory and closest approach, the gas didn't just vent, it disappeared. That disappearance might have been overlooked if not for another subtler pattern. While the CO signature fell, the infrared reflection curve of the object's surface began showing absorption lines associated with metal-Zen carbon bonds, particularly nickel tetracarbonyl, a compound that forms when nickel reacts with carbon monoxide under specific temperatures. In laboratories, this happens near 60 degrees under controlled pressure. In deep space, it is nearly impossible. Yet there it was. The reappearance of nickel tetracarbonyl in the spectra, faint but unmistakable, reignited old debates. This compound had already been detected around 3Dni Atlas weeks before, raising eyebrows because it is almost unknown in natural cosmic environments. Its structure is fragile, decomposing easily under ultraviolet radiation. The only reason it would persist near the sun is if it were being produced continuously, synthesized, not preserved. If the carbon dioxide vanished because it was chemically transformed, then the question becomes transformed into what? And by what mechanism? The reaction that creates nickel tetracarbonyl requires the presence of carbon monoxide, and that is exactly what increased as wall declined. The timing wasn't random. The fall of one mirrored the rise of the other. Something in or around the object was catalyzing carbon dioxide into carbon monoxide. binding it to nickel and releasing trace vapors into the coma. That is not geology, that is chemistry, specific, directional, and energy-dependent chemistry. Some analysts propose that intense heat could drive such a reaction naturally, reducing CO in the presence of metallic dust. But for that to happen, there would need to be consistent exposure to nickel-rich compounds and a precisely controlled thermal profile. The problem: 3Zen Atlas was rotating. Its surface experienced constant temperature fluctuation, cycling hundreds of degrees within minutes. No natural process could maintain the equilibrium required to synthesize anything. It didn't look like chaotic reaction, it looked like regulation. This realization forced researchers to confront a disturbing possibility that the CO wasn't lost randomly, it was being used. The disappearance of the gas wasn't evidence of depletion, it was evidence of consumption. A conversion process possibly tied to the heat spike and subsequent reflection pattern. In late Zen night discussions between research teams, quiet off-Jan record conversations that wouldn't survive peer review, one term began circulating: selective carbon capture. It is a phrase used in industrial chemistry, not astronomy. It described systems that trapped carbon dioxide and converted it into usable compounds using heat and metal catalysts. If that is what was happening at Perihelion, then 3Zen Atlas wasn't venting gas, it was harvesting it. Of course, that is not a claim anyone wanted to make publicly. So, the official reports bent toward the conservative. The ESA Perihelion summary stated, observed reduction in carbon dioxide levels likely due to photodissociation under extreme solar radiation. Technically plausible, but incomplete. Photodissociation would break CO into CO and oxygen. Yes, but no trace of oxygen appeared in the post-Yen perihelion spectra. The element that should have flooded the coma was missing. Instead, the oxygen seemed bound up, invisible, silent, hidden within some new compound. This missing oxygen became the quiet obsession of several labs. The University of Arizona team ran comparative models trying to simulate how much oxygen should have been released if the CO had simply decomposed. The numbers didn't fit. There was an oxygen deficit, a measurable one. Something was capturing it. Then came another clue. As the CO lines vanished, faint new absorption features appeared near 2.8 microns, wavelengths associated with carbonyl groups and organometallic complexes. These are not random emissions. They indicate structured molecules, the kind that require repeated patterned bonding. That means 3Zen Atlas's chemical composition wasn't just changing, it was organizing. It would have been easy to dismiss all of this as misinterpretation, if not for one undeniable piece of evidence. The timing: every shift, the carbon dioxide drop, the carbon monoxide rise, the nickel signature, and the change in polarization occurred within hours of each other, independent yet synchronous, as if the object had followed a chemical sequence rather than random reaction. One might call it coincidence. But coincidences don't follow thermodynamic logic so cleanly. By November 1st, the joint NASA-Zen ESA review board met privately to reconcile the data inconsistencies. Multiple attendees later confirmed that one slide, never shown publicly, contained a phrase highlighted in red: thermochemical behavior inconsistent with the inert body hypothesis. That was the moment the internal narrative began to fracture. Some insisted the object was natural but unusually metallic. Others argued it might not be inert at all, that it could contain reactive zones triggered by solar input, behaving more like machinery than rock. No one used the word device, not yet, but it hovered unspoken in every meeting, like static under a signal. Even if the mechanism were natural, its precision was staggering. The process appeared to regulate itself, converting volatiles only within a fixed temperature window. The emission spectra showed no runaway reaction, no chaos, just perfect stabilization once the object cooled below a threshold. It was as if the system had an internal cutoff, a limit it refused to cross. That kind of control shouldn't exist without feedback, and feedback implies sensing. In one of the classified analysis summaries shared between agencies, a line stood out: thermal catalytic cycling observed. Recommend treating 3Zen Atlas as a reactive system, not a passive one. Those who saw the document knew what that meant. If 3Zen Atlas was a reactive system, it wasn't merely a piece of interstellar debris. It was operating, processing solar energy, converting compounds, and responding to environmental changes with precision. And if it could regulate heat and chemistry at that scale, then what else could it control? The answer came sooner than expected. A few days after the oil readings flattened, the object's spectrographic data revealed something no one anticipated: a faint emission line repeating at exact intervals, identical to those recorded weeks earlier around the nickel compounds. It was weak, almost buried in background noise, but perfectly rhythmic, a pulse. It matched neither natural plasma oscillations nor rotational light curves. Instead, it seemed to coincide with a new pattern emerging on its surface, a faint thermal grid that rotated in sync with its motion. This was no longer about composition, it was about intent. Whatever process began at Perihelion wasn't ending. It was building towards something, and the next stage wouldn't be chemical, it would be mechanical. The first to notice the return of the nickel signature was a graduate researcher working the late shift at the Mauna Kea Observatory. It appeared faintly in the raw spectra, almost invisible against the noise floor, a delicate rhythmic fluctuation in the 3.39 micron band. At first glance, it looked like random interference. But when the signal was cleaned and normalized, a pattern emerged. Every 20-8 minutes, the same spectral fingerprint repeated. A subtle rise in emission corresponding to nickel tetracarbonyl, the same compound that had confounded scientists weeks before perihelion. No one wanted to believe it. Nickel tetracarbonyl is fragile. It can't survive direct solar radiation for more than seconds. Yet here it was reappearing after perihelion closer to the Sun than any comet should have been able to sustain it. The molecule had to be forming anew continuously, and the only way for that to happen was if some process, thermal, electrical, or catalytic, was generating it in cycles. When analysts at the infrared telescope facility CROSS-DAN checked the periodicity, they found something remarkable. The 20-8 minute cycle matched a subtle oscillation in the object's brightness curve, the same modulation first detected in its polarized light days earlier. Different instruments, different wavelengths, same rhythm. Something inside or around 3-I Atlas was pulsing, and each pulse was releasing trace amounts of nickel tetracarbonyl into space. This wasn't random. The emissions were too precise, too consistent. Nickel tetracarbonyl isn't an ordinary compound on Earth. It is produced industrially as an intermediate in nickel refining, a step used to purify metal by reacting it with carbon monoxide gas. It forms only under specific conditions, moderate heat, controlled pressure, and a catalytic surface. In other words, it requires a system, a chamber where inputs and outputs are regulated. Space isn't kind to systems like that. Yet the spectral data implied one was operating somewhere within 3-I Atlas. If the carbon dioxide anomaly had hinted at chemistry, this was chemistry with purpose. The object wasn't just reacting to sunlight, it was processing material. By November 1st, data from the Parker Solar Probe confirmed the readings. Its spectrometer detected faint metallic absorption lines consistent with ionized nickel atoms, not random vapor, but clustered in narrow bands that corresponded spatially to the object's surface. The geometry suggested localized emission points, not uniform venting. The emissions weren't spraying outward, they were shaped as if confined to channels. One mission scientist described it in an internal note as structured exhalation. The phrase didn't appear in any official release, but the idea behind it circulated quickly. If the nickel compounds were being expelled rhythmically, perhaps they weren't exhaust at all. Perhaps they were residue, a byproduct of some internal process maintaining balance. NASA's heliophysics division tried to model the behavior as natural. Their simulation treated 3-I Atlas as a layered metallic core coated in frozen volatiles. As sunlight penetrated the outer shell, trapped carbon monoxide might react with nickel inclusions, creating nickel tetracarbonyl that vented periodically as heat fluctuated. The model worked on paper, but only if the object's interior temperature stayed within a narrow band between 320 and 350 Kelvin. Observation showed it hovering exactly there. For a natural body, maintaining that thermal stability while spinning under solar radiation is impossible. Comets fluctuate violently, hot on one side, freezing on the other, but 3-I Atlas's temperature distribution was even as if controlled. Something was moderating the heat, keeping it locked in range. At this point, one question dominated every internal discussion. Was the object regulating itself? The idea felt absurd. Space objects don't regulate anything, they react blindly to physics. But all the evidence pointed in the opposite direction. Stable temperature, cyclic emissions, rhythmic spectral pulses, layered reflectivity. Each piece alone could be coincidence. Together, they formed a system. That system appeared to rely on nickel, specifically on how nickel interacts with carbon monoxide to form and then decompose nickel tetracarbonyl. When the compound breaks down, it releases pure nickel and carbon monoxide again, an exothermic reaction. On Earth, Metallurgists use it to deposit thin, uniform nickel coatings. It is called the Mond process. Here, in the vacuum of space, it might be something else entirely. A self-gen sustaining reaction turning solar heat into chemical work. To an engineer, that would look like a heat engine. To an astronomer, it looked like a paradox. Some began wondering if they were watching a kind of chemical oscillator, a natural machine driven by sunlight cycling between absorption and emission using nickel as a catalyst. But the precision undermined the natural part. The cycles were consistent within fractions of a second, unaffected by rotational distance. When plotted over time, they formed an almost perfect sine wave. And then came the sound. Not sound in the ordinary sense, but frequency. Radio telescopes tuned to 3Dni Atlas's coordinates began detecting a faint repeating oscillation at 5.3 Hz. The same rhythm buried beneath the post-Dien Perihelion silence. At first, it was dismissed as instrumental feedback, but when the frequency was converted to audio, the pattern emerged clearly. Modulation, silence, modulation, repeating, unwavering. The signal wasn't data-den rich, but it was structured. Its amplitude varied with the same 20-den-8 sample as the nickel emission each time the compound's spectral intensity peaked. The radio pulse followed. The link was undeniable. That is when someone, an analyst at ESA's mission control in Darmstadt, noticed the metaphor staring them in the face. Nickel tetracarbonyl is both highly toxic and highly reflective. It absorbs certain wavelengths while releasing others. The pulse, the light, and the chemical reaction were all doing the same thing, absorbing and releasing in perfect rhythm. The object was, in a very literal sense, breathing. The nickel echo, as it came to be called, became the focus of joint analysis. Every 20-gen-8 minutes, 3Dni Atlas inhaled and exhaled in light and radio, synchronizing with a thermal beat that should not exist in a lifeless body. The process generated minute but measurable thrust, a repeating push like the heartbeat of an engine idling in deep space. Publicly, the data was dismissed as instrumental cross-gen modulation. Privately, agencies began using a different vocabulary. Terms like adaptive feedback loop, thermal cycling stability, and even phase synchronization words borrowed from systems engineering, not astrophysics. Then a new layer of complexity appeared. When the nickel pulses were overlaid with trajectory data, a subtle correlation emerged. Each emission coincided with a micro-Zan oscillation in velocity, a push opposite the direction of solar wind. Over the course of a day, those micro-Zan adjustments added up to a measurable correction. 3Dni Atlas was holding position against radiation pressure. That should have been impossible. For any object under solar radiation, even minimal drag or outgassing should push it gradually off course. But 3Dni Atlas wasn't drifting. It was maintaining its vector as if compensating for external forces. Every time sunlight tried to push it off path, a pulse followed, a small exhale of nickel compounds that restored balance. It wasn't flying blindly through space, it was navigating it. By November 2nd, cross-gen agency coordination had quietly shifted from observational to operational. There were now discussions not about what 3Dni Atlas was, but about what it might do, if it could adjust trajectory. Could it also accelerate? Was it still responding to the sun, or had it begun responding to something else? A classified briefing circulated between NASA, ESA, and the CNSA China National Space Administration carried an understated but chilling line. Object exhibits cyclical self-gen corrective dynamics consistent with active stabilization. The nickel echo wasn't just a chemical curiosity. It was evidence of control, precise, measured, repeatable control. And soon after, something happened that made that conclusion impossible to ignore. During one of those 20-gen-8 minute cycles, as the nickel emission peaked, the object's rotational axis shifted, a small sudden precession that altered its orientation by nearly 4 degrees. Then in the next cycle, it shifted again in the opposite direction as if testing balance. The motion wasn't random drift, it was targeted, deliberate, and repeated at exact intervals. After that, the nickel emission stopped. The object went dark again. No radio pulses, no thermal oscillations, no gas release, just silence heavier than before. But the silence didn't mean stillness. It meant waiting. Because within hours, 3Dni Atlas would do something no natural comet ever had. It would change its path. When the telemetry resumed after the last nickel pulse, the first change was almost invisible, a fractional deviation in the object's light curve. It wasn't brightness or trajectory this time, it was rhythm. The rotation period, once stable at 3.24 hours per spin, had shifted to 2.91. That might sound minor, but for an interstellar object of that mass and size, it was extraordinary. No known mechanism could explain a rotational acceleration of that magnitude without fragmentation. Yet, 3 Deni Atlas remained perfectly intact. Every comet that experiences a spin change does so through asymmetric jets, uneven gas vents that push the body slightly faster or slower. But all visible activity from 3 Deni Atlas had already ceased. There were no plumes, no dust tails, no emissions of any kind. The rotation speed simply changed silently and then stabilized at the new rate. When the Parker Solar Probe compared its magnetometer data from before and after the adjustment, it found something else. A faint transient electromagnetic pulse preceding the rotation change by roughly 9 seconds. It wasn't strong, but it was sharp and localized, centered precisely where 3 Deni Atlas should have been. It looked like a spike of induced current, as if something inside the object had discharged. The waveform was consistent with an internal electrical realignment, a short, concentrated burst of energy. That was the first clue that the spin wasn't caused by external forces at all. It came from within. At NASA's Jet Propulsion Laboratory, analysts ran through every natural explanation they could imagine. Mass shedding, no debris. Tidal torque, the sun was too far. Collisional impulse, nothing nearby. Outgassing, the ore and nickel emissions had already flatlined. There was no visible expulsion of mass, no reaction force to account for the sudden spin zen up. The object had changed its own motion without losing energy to the environment. That shouldn't happen. It violates the conservation of angular momentum unless there is an internal redistribution of mass, something shifting inside. That is when attention turned to the object's core. Radar modeling from perihelion data had already suggested a dense, possibly metallic nucleus beneath a thin reflective layer. If that core could move independently, even by a few meters, it could alter the moment of inertia, changing the spin rate without external thrust. But that would mean the interior wasn't solid. It would mean compartments. The word compartments appeared for the first time in an internal ESA report dated October 30, Gen 1st. The phrasing was careful. Observed rotational variance may indicate internal differentiation of mass. That is scientific shorthand for something much less comfortable, internal movement. When the spin rate stabilized at 2.91 hours, the object began exhibiting another behavior. Its rotation axis tilted not randomly, but toward the ecliptic plane, the flat disk along which the planets orbit. The tilt measured about 12 degrees, aligning 3 Deni Atlas more closely with Earth's orbital path. That realignment wasn't just spatially improbable, it was strategic. By changing its axis, the object minimized the effect of solar radiation torque, achieving near-Zen perfect rotational equilibrium. If that adjustment was intentional, it wasn't for survival, it was for stability. As the axis shift unfolded, telescopes observed a faint brightening at the object's poles, not flares, reflections, like two mirrors catching sunlight from alternating angles. It was as if the poles themselves were adjusting reflectivity in sync with the rotation. Every half-turn, a glint. Every full rotation, a pulse. That glint pattern wasn't random either. When mapped over several hours, it repeated at fixed intervals, producing a repeating Morse-gen-like cadence. 3 bright flashes, 1 dim, 2 bright pause over and over. The spacing between pulses matched the same 20 Gen 8 Gen minute rhythm of the nickel echo, now expressed through light instead of radio or chemistry. It wasn't emitting anymore, it was signaling. Of course, no one said that out loud. The word signal carries weight and weight becomes headlines. Instead, the internal phrasing evolved again, periodic albedo modulation, a neutral phrase to describe what was functionally a deliberate optical code. At the Chinese Chang'e monitoring array, infrared sensors recorded a complementary phenomenon, heat signatures on the object's surface fluctuating in lockstep with the optical pulses. Each bright flash corresponded to a localized thermal increase at one pole, then the other, alternating perfectly like capacitors, charging and discharging on a cycle. It wasn't energy loss, it was energy transfer. Whatever was happening, it followed a logic. The pattern wasn't static, it adapted. When the object's spin accelerated slightly during the second cycle, the flash spacing adjusted to compensate, preserving the 20 Gen 8 Gen minute rhythm. That is not coincidence. That is correction. Something within 3 Deni Atlas was monitoring its own rotation and responding in real time. At this stage, the data coming from independent telescopes began diverging from the official feeds. Amateur astronomers tracking the object's light curve noticed that the brightness peaks weren't smooth. They had fine ripples, Micro-Zen flickers within each major pulse. Those flickers repeated in precise mathematical intervals, 1 second apart, exactly 60 repetitions per minute. No natural object produces such temporal precision. That kind of timing suggests synchronization, possibly between different surfaces or internal systems oscillating together. When the University of Tokyo Space Science Department overlaid the flicker frequency on the object's Doppler drift, a strange harmony appeared. The micro-Zen oscillations matched the predicted resonance frequency for a hollow metallic sphere of roughly the same mass and diameter. In simple terms, the object was vibrating at a tone that matched its own shape, like a bell being rung by something inside it. The rotation, the tilt, the light, and the resonance were all connected, parts of a single event unfolding with methodical precision. Then, just when observers thought the motion had stabilized, it happened again. At 0:3:17 UTC on November 1st, 3 Gen I Atlas's spin slowed abruptly, not gradually, but in one continuous deceleration lasting about 12 minutes. During that time, its brightness dimmed by 20%, then returned to normal. The slowing was so precise it followed a near-den linear deceleration curve, the kind of slope you'd see in an engineered braking sequence. When it stopped, the rotation rate settled at exactly 3 hours per cycle. Not 2.99, not 3.01. A perfect integer objects in space don't round themselves off to whole numbers. Systems do. The phrase integer stabilization appears in the classified section of ESA's internal memo from November 1st. It is the kind of phrase that shouldn't exist in astrophysics. The implication was unavoidable. The object had deliberately adjusted its rotation to a clean 3 10-hour period, whether that was for energy optimization, orientation, or something else. No one could say. The reaction among scientists ranged from awe to discomfort. One senior astronomer described it bluntly. "We are watching something self-gen regulate. After the adjustment, every parameter, brightness, temperature, polarization, and radio flux leveled into quiet equilibrium. The system had balanced itself as if completing a calibration, but in the hours that followed, one final twist emerged. The acceleration and deceleration had affected its trajectory subtly, but enough to be noticed. Its outbound path, which should have continued cleanly away from the sun, began to bend ever so slightly. The change was small, less than 0.05 degrees, but statistically undeniable. Something about the spin event had imparted a lateral force, shifting its course by millions of kilometers over time. For the first time, 3 Gen I Atlas wasn't just maintaining orientation, it was moving by choice or by consequence into a new trajectory. And that shift led directly to the event that sent the entire monitoring network into silence. Because as soon as the object's path began to change, every major space-gen-based observatory, Parker, Solar Orbiter, and SOHO simultaneously lost tracking lock at the same second. It started at 0:5:12 UTC on November 1st. The time burned now into every observatory's logbook. The Parker Solar Probe was the first to lose lock. Its tracking sensors, calibrated to follow 3 Gen I Atlas's heat and reflected light, reported a sudden drop in signal strength. For 3 seconds, the readings fluctuated, then flatlined. The system automatically switched to secondary acquisition mode, sweeping across the expected coordinates. Nothing. The object was gone. 6 seconds later, ESA's Solar Orbiter reported the same failure. Its onboard coronagraph, tuned precisely to the object's visual signature, couldn't reacquire it. Then SOHO followed. In less than a minute, every major solar observatory lost contact, not sequentially, but simultaneously. That kind of failure shouldn't be possible. These satellites are separated by millions of kilometers, each operating independently, each using distinct frequency bands and pointing algorithms. For all of them to lose tracking at once, something had to have occurred in the one place they shared, the sky itself. The first hypothesis was software, a synchronization bug perhaps, or a telemetry error caused by the recent spin anomaly. But system logs didn't show malfunction. The sensors were healthy, the alignment stable, the instruments were functioning perfectly. They simply had nothing to lock onto. 3 Gen I Atlas's light had vanished. When data analysts began cross-gen referencing timestamps, they discovered something even more peculiar. The tracking loss aligned precisely with the moment the object's outbound trajectory deviated. The same 0.05 degree shift detected minutes earlier. The disappearance wasn't random. It coincided with movement. For a brief moment, it was as though the object had stepped sideways out of the line of observation. Telescopes on Earth were still collecting data at the time. The Atacama Array in Chile and the Haleakal Observatory in Hawaii both caught the same phenomenon. The object's brightness dipped sharply as if a curtain had dropped over it. When visibility returned, 3 Denai Atlas was no longer where it should have been. It had moved several arcseconds off course, enough to suggest a velocity change inconsistent with gravitational drift. The standard orbital model couldn't explain it. Solar wind pressure, radiation drag, thermal recoil, none produced the directional magnitude observed. Whatever force acted on it was internal, instantaneous, and perfectly aligned with its new heading. In other words, it maneuvered. But that word didn't appear in any report, not publicly. The official explanations circulated in coordinated press releases described the event as a temporary signal interruption caused by background interference from solar plasma, a phrase designed to sound plausible and harmless. Privately, however, the data told a different story. When telemetry was restored hours later, the object's coordinates placed it slightly above the ecliptic plane, a few thousand kilometers higher than expected. That is not an error margin, that is propulsion. The trajectory curve resembled a controlled arc, as if it had applied a brief impulse to correct or alter its outbound path. The burn, if that is what it was, lasted less than a minute. Yet its precision was surgical. The new course wasn't random. It led directly toward the plane of Earth's orbit. By early morning, the term vector realignment appeared in multiple agency communications. It was the sanitized way of describing what everyone privately called a turn. What puzzled mission engineers most was how invisible it had been. No jets, no flare, no debris. Whatever force moved it left no visible exhaust that ruled out standard outgassing. The impulse was clean, pure momentum shift like a magnetic or radiation jan-based thrust. A physicist at Caltech described it bluntly. We saw acceleration without reaction mass. That is not propulsion as we know it. The comment didn't make it into the public log, but the strangest part wasn't that it moved. It was how it vanished while doing it. When the object's brightness dipped, it didn't fade gradually as dust clouds or shadows do. It disappeared almost instantly, dropping below detection thresholds across multiple wavelengths simultaneously. The optical fade, infrared cooling, and radio silence all occurred in unison within milliseconds of the trajectory shift. It was as if the object had changed its surface properties in an instant, switching from reflective to absorptive. Some speculated this could be due to orientation, the reflective surface turning edge gen onto Earth and telescopes, but the degree of brightness loss didn't match that geometry. It was too extreme, a reduction by a factor of more than 10,000. Even a perfect mirror turning sideways wouldn't vanish so completely. Something had masked it. When the solar orbiter's telemetry finally reacquired the object, its polarization signature was inverted again, returning to positive, the normal state for diffused dust. But there was no evidence of dust. The coma hadn't returned. The inversion seemed synthetic, like a camouflage, the optical equivalent of noise. The term used in one ESA memo was radiative decoupling, which described an unknown mechanism by which an object could suppress its own light-scattering behavior, effectively making itself invisible to polarized detection. The physics behind that concept were untested, but the data was there. 3 Denai Atlas had turned off its visibility, and it did so at the exact moment every observatory was looking. After the event, an emergency coordination call was held between NASA, ESA, and the Chinese National Space Administration. The call summary later leaked contained only one line under key findings. Simultaneous loss of lock across independent networks suggests active electromagnetic interference or deliberate sensor suppression. In plain language, it jammed the instruments. The concept of a natural object capable of electromagnetic interference is absurd. Comets don't produce coherent fields strong enough to disrupt solar observatories, but 3 Denai Atlas had already defied natural categories, regulating its temperature, aligning jets, modulating polarization, even adjusting its rotation. Suppressing detection was simply the next logical step. For almost 7 hours, it remained invisible to all instruments. During that time, no visual or radio data existed, just an empty section of sky where something enormous should have been. Then shortly before 1200 hours UTC, the object reappeared, not where it had been, but tens of thousands of kilometers along its new trajectory. Its velocity was lower than predicted, its rotation unchanged, and its spectral profile muted. The surface reflectivity had decreased by almost half. It had gone dark, moved, and remerged quieter, colder, and seemingly steadier than before. To anyone following the data, it was as if the object had executed a controlled course correction under a veil of invisibility. Officially, that interpretation was forbidden. The word maneuver was replaced with positional drift. The phrase loss of lock became temporary observational uncertainty. But inside the closed communication loops between agencies, the tone shifted. The data had crossed a threshold. A note from the Solar Orbiter mission director summarized the mood bluntly. "We're no longer observing a passive body. This is active navigation." After that, the data sharing between agencies began to splinter. Each network started encrypting its transmissions. Public dashboards that had streamed live telemetry for months went offline. What remained visible to the public? Trajectory plots, brightness charts, orbital updates froze in place, all marked pending verification. Behind those walls, however, scientists were already studying something else. A brief infrared image captured during the blackout window. The image came from China's Chang'e observation network, which had been scanning the inner solar regions at the time. It was only a few pixels wide, distorted by glare and noise, but it showed something no one expected. A heat bloom, not circular but angular, like a shape, and within hours of its discovery, it disappeared from the network entirely. The image would later be referred to only by a code name whispered among analysts, the Chinese window. The image was never meant to exist. It appeared for less than 3 hours on the internal server of the Chang'e Deep Space Monitoring Network before vanishing, deleted, archived, or buried. No one knew. But during that small window, a few researchers managed to download it, and what they saw turned the entire investigation inside out. At first glance, it looked like a routine infrared snapshot. A small high-Zen temperature bloom just above the solar limb captured at 0514 UTC on November 1st, precisely within the tracking blackout. But the heat signature was wrong. Instead of a diffuse comet Zen-like smear, it was sharply defined, geometric, a concentrated angular source with boundaries too straight to be natural. One Chinese analyst speaking anonymously weeks later described it in simple terms. It didn't look like a plume, it looked like a structure. The object in the frame had a temperature differential, hot in the center, cooler along symmetrical edges, and most importantly, a flat baseline. That baseline aligned perfectly with the plane of the sun's equator, suggesting orientation. In infrared, it resembled an isosceles triangle, faint, hazy, but distinct, with the apex pointing away from the sun. It wasn't a perfect triangle. One edge seemed to curve inward like a recessed contour, a shadow line too deliberate to be coincidence. When converted into visible wavelengths, the object's outline almost disappeared. It was the thermal profile that made it visible at all, as if the thing wasn't emitting light, only heat tightly confined to its surface. That single frame raised impossible questions. If it was 3Deni Atlas, it had changed shape. No known physics could explain a natural body morphing from an irregular tumbling mass into something with measurable symmetry. Yet the coordinates matched exactly. The Chinese team crossed and checked them against ESA's last known position from before the blackout. The same spot, same time, same arc of movement. They named it informally the window because it looked like one. A glowing aperture in the dark. The internal report that accompanied the image, written in Mandarin and later partially translated, described the detection as thermal emission, possibly consistent with structured reflection. That phrase caught the attention of every Western agency monitoring the situation. Within hours, the file was classified as restricted. The image was pulled from public servers and access logs were sealed, but not before copies spread. By November 2nd, several European astrophysicists had received the file via encrypted channels. The metadata confirmed authenticity. The timestamp aligned with the global tracking loss. The image hadn't been fabricated. It came directly from Chang'e's infrared array. When a team at the European Southern Observatory enhanced the thermal map, they found faint secondary features extending from the triangle's base. Parallel striations evenly spaced, each about the same width. Not natural fractures or streaks, but patterns, the kind created when heat radiates off structured surfaces like panels or ridges. And then there was the reflection. At the triangle's apex, a small, cold indentation appeared, a shadowed zone that absorbed rather than emitted infrared. Its edges were perfectly smooth, curved like a dish. If that shape was real, it could only mean one thing: concavity. To describe that in plain terms, the object had a hollow dish gen-like depression facing away from the sun. In a purely natural scenario, that makes no sense. Comets erode unevenly. Their surfaces crumble, collapse, but they don't form clean concave shapes that maintain orientation. That is design, or at least something acting like design. For the next 48 hours, that single image became the quiet epicenter of the 3Deni Atlas debate. On encrypted message boards used by astrophysicists, threads exploded with analysis. Some argued the triangle was an artifact of image compression. Others swore it showed a surface structure. One prominent researcher from the University of Toronto wrote, "If this is a thermal diffraction artifact, it is the most symmetrical one in solar history." But as fast as the debate began, it ended. By November 3rd, every post referencing the image had been deleted. Users who shared it received messages warning of data security violations. Within hours, the discussion vanished from the public internet entirely. That silence was confirmation enough. Something in the frame was real and inconvenient. Meanwhile, agencies issued denials. The Chinese Space Administration claimed the image was misinterpreted thermal noise. NASA refused comment. ESA said they hadn't independently verified any anomalous shape, but internally teams were already working on spectral overlays, comparing the Chang'e data to Parker Solar Probe readings during the same time window. What they found made denials impossible during the blackout. Parker's magnetometer had registered a faint but repeating magnetic pulse, low frequency, almost rhythmic, when the data was correlated with the Chang'e timestamp. The pulses aligned perfectly with the duration of the infrared flare. Each pulse lasted 1.3 seconds, separated by exactly 5 seconds of silence. 5 seconds, then another pulse. 5 seconds, then another. 8 in total, 8 pulses. The same number of bright glints recorded by ground-SAN-based telescopes in the minutes before tracking loss. Optical, magnetic, thermal, all synchronized. This wasn't static, it was sequence. The implications were staggering. For 8 cycles, 3 Denai Atlas, or whatever it had become, appeared to emit coordinated bursts across multiple spectra while executing its trajectory shift. Then it vanished. That combination of actions, simultaneous magnetic, optical, and thermal pulses, has only one parallel, signaling. But signaling to whom? Some speculated it was scanning, mapping the surrounding solar environment using electromagnetic bursts. Others whispered it was communication, either outbound or responsive. A few went further, suggesting that the pulses were part of an activation, that the object's entire perihelion sequence had built toward this. The heat spike, the jet alignment, the silence, the polarization inversion, the chemical conversion, all stages of a process culminating in the window. The geometry of that shape didn't help calm anyone's nerves. In subsequent reconstructions, analysts noted that the triangular outline wasn't equilateral. Its lower edge appeared slightly curved like a shield. When its proportions were compared to the radiation patterns recorded by Parker, the correlation was uncanny. The heat bloom's angles matched the magnetic field's orientation vectors. In other words, the thermal image wasn't random. It depicted the same geometry as the electromagnetic signature. That geometry would appear again later, faintly echoed in new optical frames once 3 Denai Atlas remerged. But in this first instance, the Chang'e window, it was pure, sharp, undeniable. One astrophysicist summarized it best in a note that was never meant for public release. The Perihelion event was not destruction, it was unveiling. After that, the narrative changed forever. No one publicly mentioned the image again, but the internal memos began using new terminology, surface morphology, thermal patterning, and most notably possible shielding configuration. The phrase shielding configuration appeared 3 times in the ESA-GEN-CNSA joint analysis draft before being struck out. The implication was clear enough. The shape wasn't random heat, it was function, a form designed to endure proximity to the sun. If that was true, then perihelion wasn't a test. It was a maneuver. The object hadn't been destroyed by the sun, it had used it, and whatever shielding system activated at the moment was still operating. The infrared flare was the first hint of that mechanism, but in the days that followed it would reveal itself again, this time not as a light or heat, but as an absence, a narrow, precise shadow cutting through the solar wind, something invisible yet measurable, as if 3 Denai Atlas had wrapped itself in protection. For days, the Chang'e image haunted every analysis meeting, every encrypted thread, every whispered conversation among scientists who were supposed to know better than to believe what they were seeing. A geometric thermal bloom above the sun caught only once, then erased. It shouldn't have been possible, but the more the data from other instruments came in, the harder it became to deny what that single frame implied. Whatever happened to 3 Denai Atlas at perihelion, it wasn't destruction, it was adaptation. The first clue came from Parker Solar Probe's plasma detectors. 3 hours after the blackout, the probe passed through a region of space directly downstream of the object's new trajectory. It detected a sudden narrow drop in solar particle density, a literal void in the solar wind. not awake. Not turbulence, but silence. For a distance of nearly 2,000 kilometers, the stream of charged particles thinned to near zero before returning to normal. That kind of void can't exist naturally near the sun. Solar wind doesn't carve holes, it fills them, but something had displaced it. Not deflected, displaced. The Parker team called it an anomalous plasma cavity. It moved with 3Dni Atlas matching its projected course perfectly. The only known way to create such a cavity is through magnetic confinement by generating a local field strong enough to push back against the solar plasma, creating a shielded zone. On Earth, we do it in laboratories, inside fusion reactors using immense power to trap plasma inside magnetic bottles. But in space, no natural body can generate a field like that, especially not one smaller than a moon, unless the field wasn't magnetic in origin, but electromagnetic induced by motion, charge redistribution, or deliberate modulation. The readings supported that idea. The plasma cavity's boundaries pulsed faintly in rhythm with the same 20-10-8-10 minute cycle that had defined every other anomaly since perihelion. The nickel echo, the optical flashes, the radio pulses. That consistency was impossible to ignore. The shield wasn't static. It was breathing, expanding, and contracting like a living field. At first, mission scientists assumed the data was corrupted. Perhaps Parker's sensors had glitched under solar interference. But when ESA's solar orbiter passed through the same region nearly 12 hours later, it recorded the same pattern, an area of depressed particle density, faintly charged, moving outward from the sun with the object. The void was real, and its geometry matched the shape captured by Chang'e. The same triangular base with a curved leading edge. It was as if the heat signature from the infrared image had solidified into a force field, a shielded region with the same proportions. No one wanted to call it shielding. The term didn't fit astrophysics, it belonged to engineering. But when the plasma distribution maps were reconstructed in 3 dimensions, there was no other word. The cavity acted exactly like a defensive layer, absorbing and redirecting solar radiation. It maintained a constant standoff distance, always 400 kilometers thick, regardless of solar wind pressure. That kind of equilibrium isn't natural. It is feedback controlled. A NASA engineer described it succinctly in an internal note. Whatever this is, it is managing its own environment. He wasn't exaggerating. Inside the cavity, radiation levels dropped dramatically, temperature gradients flattened, and even electromagnetic interference decreased. The object had carved out a pocket of calm in one of the most violent regions of the solar system. A silence in the storm. ESA scientists began referring to it as the bubble. It moved with the object, wrapped around it, and reacted instantly to solar fluctuations. When the sun emitted a minor flare on November 2nd, the bubble's outer layer shimmered, expanding slightly before contracting again, dissipating the shock wave. That is not passive resistance, that is active counteraction. The data pattern looked eerily similar to magnetohydrodynamic feedback, the same principle used in experimental plasma containment. But there is a key difference. Human systems require massive energy input. 3Dni Atlas seemed to generate the same effect effortlessly, powered only by its proximity to the sun. That realization led to a chilling possibility. The object wasn't protecting itself from the sun, it was using the sun to power the shield. The heat spike during perihelion, the controlled jet, the oil conversion, the nickel synthesis, all of it could have been preparation for this. Each stage gathering energy, refining material, building charge, and at the moment of closest approach it deployed it. The perihelion event wasn't random chemistry, it was ignition. In that model, the nickel-Zen-carbon reactions acted like a capacitor, converting solar heat into stored chemical potential, which was then released as electromagnetic energy to form the shield. A self-gen sustaining loop powered by sunlight. The Chang'e thermal triangle wasn't a flare, it was the birth of containment. For most astronomers, that interpretation was unthinkable. A natural object performing energy conversion and field generation borders on science fiction. But the numbers didn't lie. The energy deficit expected from solar heating at that distance simply didn't appear in the data. 3Dni Atlas absorbed far less radiation than predicted, as if it had become reflective to more than just light. Radiation models showed a drop of nearly 97% in absorbed energy once the bubble stabilized. It wasn't cooling. It was reflecting energy back outward, redirecting it away from its surface. That is not survival, that is control. A physicist at the European Space Research and Technology Centre reviewing the dataset in early November wrote privately, "We're no longer looking at material composition, we're looking at behavior." As the bubble expanded, Parker Solar Probe's magnetometers detected faint oscillations within its boundary. These oscillations weren't random. They formed standing waves, interference patterns locked in harmonic resonance with the object's spin rate. That synchronization shouldn't be possible unless the field was phased, adjusted dynamically to match rotation. That detail broke even the most skeptical minds. Random plasma can't tune itself. It can't phase-gen lock to a rotating body without active modulation. The shield was aware of its own movement. By November 3rd, the phenomenon reached its peak. The cavity widened, stretching tens of thousands of kilometers outward, deflecting solar wind like a bow wave. Then, without warning, it began to contract slowly, methodically, until it matched the object's new, cooler profile. When the process ended, 3Dani Atlas appeared almost inert again, wrapped in invisible equilibrium. It had entered what mission reports would later call the quiet phase. Inside that quiet phase, everything stabilized. Temperature, spin, reflectivity. The shield didn't vanish, it simply dimmed, becoming transparent to light but opaque to charged particles. For the first time since Perihelion, the object showed no measurable change. But for all that stillness, there was one detail no one could explain. Inside the cavity, Parker detected weak echoes of high-den frequency radiation, faint, almost ghostly, repeating every 1.6 seconds. The signals weren't strong enough to transmit information, but they weren't random either. They matched the harmonics of the standing waves within the field. Those who saw the data began to wonder, was the shield also a form of communication, a resonant pattern broadcasting internally or outward, modulating the very plasma it displaced? If so, the object wasn't just protecting itself. It was transmitting through its own armor. Whatever it was doing, it seemed deliberate, calculated to balance energy, repel plasma, and sustain itself indefinitely. But then, one last anomaly appeared, the most unsettling of all. When the plasma cavity's movement was extrapolated using Parker and Solar Orbiter's data, analysts realized that the field wasn't symmetrical. It wasn't a sphere or an ellipsoid, it was directional. The cavity opened along a vector, a narrow cone pointing directly away from the sun, a corridor aligned with the object's new trajectory. Not a shield, a path, as though 3Dani Atlas had created a window not to protect itself from solar radiation, but to accelerate through it. And that realization changed everything, because what came next wasn't just another anomaly in light or chemistry. It was a void, a deliberate engineered gap in observation that no one could explain. A gap that lasted exactly 40-3 minutes. When the perihelion shielding data came in, most assumed the strange calm that followed meant the event was over. The object had stabilized, the sensors had quieted, and the sun had resumed its regular rhythm. But at 14:12 UTC on November the 3rd, something broke the silence. It wasn't a flare or a pulse. It was nothing. Every major observatory, Parker Solar Probe, Solar Orbiter, Stereo Xen-A, and multiple ground Xen base stations, all stopped receiving usable data from the region containing 3Dani Atlas. It didn't happen gradually, it was instantaneous. One moment, telemetry flowed normally. The next, every stream froze. 3 minutes later, the feeds resumed perfectly synchronized across all networks. The time gap was identical down to the second. To the public, it was a technical glitch. To the engineers reviewing the raw logs, it was something else entirely. Because those 3 minutes didn't behave like a blackout, they behaved like deletion. When communication is lost due to solar interference, instruments show noise, static, chaotic packets, corrupted fragments. But in this case, there was nothing. The data stream didn't degrade, it went flat. No spikes, no dropouts, no interference, just an empty sequence of zeros recorded cleanly, as if the instruments had continued working, but had nothing to report. In one internal ESA memo, an engineer described it with clinical precision. Sensors did not fail, the environment ceased to exist. It wasn't hyperbole. Every instrument that measured the solar environment plasma, light, magnetic flux, radiation density, registered zero variance for the entire duration. The sun, for that window of time, produced no measurable activity in the region around 3Dani Atlas. That is not possible. The sun doesn't stop. When analysts tried to reconstruct the missing window, they noticed something even stranger. The gap wasn't random in timing. It began exactly one full rotation after the object's final spin alignment, precisely when the shielding field had fully stabilized. The gap, it seemed, was part of the sequence. NASA's Deep Space Network, which hadn't been actively tracking the object, recorded faint anomalies in its background telemetry during the same period. ghost echoes in the X-Gen band repeating every 11 seconds. The pattern matched the harmonic resonance of the plasma cavity surrounding 3Gen I Atlas. In other words, the field didn't collapse during the gap. It expanded so far and so suddenly that it swallowed the sensors observing it. The 40Gen 3 minutes weren't absence, they were containment. That idea spread quietly through research networks. What if 3Gen I Atlas had activated its shield, not to protect itself, but to obscure something? Within hours, that theory gained support from a single accidental clue. The Stereoxena spacecraft orbiting at a slightly different angle from Earth recorded a brief spike just before the gap began. One bright narrow emission line in the ultraviolet range lasting less than 2 seconds. It wasn't solar. The wavelength didn't match any known atomic transition from solar material. It was too short, too pure, and it came from the exact coordinates of 3Gen I Atlas. Then the line disappeared and the 40Gen 3 minutes began. The signal was faint, but its spectral signature was unmistakable. A coherent ultraviolet emission at 150 Gen 5 nanometers, sharply focused with almost no dispersion. That is not radiation, that is a beam. When data returned, the emission line was gone. 3Gen I Atlas's position had shifted again, only slightly, but now farther from the sun than before, moving smoothly along its outbound vector. The shield had contracted, the plasma density normalized, and the instruments resumed as if nothing had happened. No debris, no outgassing, no thermal residue, just silence and a course correction. The recovery data showed that during the gap, the object had decelerated. Its velocity dropped by about 20 Gen 2 meters per second, a tiny adjustment, but enough to change its long Zan term trajectory. The deceleration couldn't be explained by drag. There was nothing to slow it down. The only possibility was internal braking that matched the pattern seen after every previous anomaly. Acceleration, stabilization, reorientation, now deceleration. Like the final step in a controlled maneuver, but a maneuver toward what? In the hours after telemetry resumed, agencies quietly compared notes. The Chinese Chang'e team reported a faint afterglow near the object's trailing path, a thin streak of ionized particles curving along its wake. It wasn't dust, it was plasma, magnetically aligned, as if tracing invisible field lines left behind. One engineer described it poetically, almost reluctantly, like contrails in the solar wind. That streak persisted for nearly an hour before dissipating. When analyzed, its composition didn't match the sun's plasma or any cometary debris. It contained nickel ions, the same compound from the earlier emissions, but fused into microscopic filaments. Each filament aligned perfectly with the direction of the ultraviolet beam recorded before the blackout. In other words, the beam hadn't been random light. It had carried matter. The question no one wanted to ask became unavoidable. Was 3Gen I Atlas ejecting something or sending something out? That is when the timeline collapsed into speculation. Some believed the 40Gen 3Gen minute gap represented a data blackout caused by a sudden electromagnetic surge. Others argued it was a deliberate emission event, a controlled discharge of material or signal. A few, more quietly, suggested it was something else entirely, the completion of a process that began at Perihelion, a system activating, operating, and then once finished hiding its signature. In a joint internal debrief on November 4th, one senior ESA physicist summarized the situation in a single line that froze the room. If the data gap was concealment, then what we missed wasn't noise, it was the purpose. When data resumed, 3Gen I Atlas was quiet. Its shielding field had stabilized. The plasma cavity shrank. The rhythmic pulses stopped. Every measurable variable flattened to background levels. The object appeared inert again, just a faint cold silhouette coasting outward from the sun. But beneath that calm, there was one last clue. At the very edge of the 40Gen 3Gen minute window, the final recorded packet before the blackout. A single data line from the solar orbiter's magnetometer contained a subtle anomaly. A frequency spike lasting only 0.02 seconds. When converted into sound, it wasn't random static, it was tonal. A single note sharp and pure at 440 Hz. Concert pitch A, a tone so familiar it seemed almost impossible. After that, nothing. Every instrument resumed as if nothing had happened. The sun was still there. The field was gone, and 3Gen I Atlas drifted on. But to those who'd seen the data, that silence wasn't closure. It was the start of a new question. One that would unravel every assumption about what they'd been studying. Because when the telemetry reappeared, 3Gen I Atlas wasn't alone. Another echo, faint, distant, following its path, had appeared on the far side of the solar field. When the data streams recovered after the 40-3 minute void, the first reaction across mission control was relief. Every instrument came back online without damage. The telemetry looked normal, radiation levels were stable, solar activity unchanged, and the object, faint, cool, unremarkable, appeared to be exactly where physics said it should be. For a few minutes, it almost felt like the story had ended, but then the anomaly appeared. Quiet, almost insignificant at first, a secondary trace, faint but unmistakable, moving parallel to 3Den'i Atlas along the same outbound vector. It wasn't a reflection or a ghost signal. It was another source of light, smaller, colder, but perfectly synchronized. At first, engineers thought it was an echo. Spacecraft often produce data ghosts when instruments recalibrate after high radiation events, but this echo didn't fade. It maintained consistent magnitude and distance, trailing exactly 18,000 kilometers behind 3Den'i Atlas. That spacing stayed constant for hours. The two objects, one large and faint, one smaller and colder, moved together in lockstep. The immediate conclusion was fragmentation. Perhaps the perihelion stress had split the nucleus in two, creating a secondary fragment. But that explanation failed almost instantly. The new trace wasn't tumbling. It wasn't outgassing. It wasn't even decaying in brightness. It was stable, eerily stable. When radar backscatter models were run using Parker and solar orbiter data, the smaller body showed a cross-Jan section far too smooth for a natural shard. Its radar reflectivity oscillated rhythmically with clean transitions rather than chaotic ones. In other words, it rotated, but with precision, like a satellite maintaining orientation rather than debris spinning in chaos. That realization hit hard. If the smaller object was a fragment, it was one that moved and stabilized itself immediately without losing alignment. The odds of such behavior occurring naturally are virtually zero. When analysts mapped its trajectory, the relationship between the two bodies became impossible to ignore. The smaller trace wasn't drifting randomly. It was accelerating toward the main object at a slow, controlled pace, closing the gap by about 50 kilometers per hour. Its motion was deliberate, measured. It was returning, hence the name that quickly circulated among mission teams. The Reed's entry vector. It wasn't clear which body had initiated the maneuver. Maybe the main object had ejected it. Maybe it had detached on its own, but the symmetry of their motion suggested coordination. The smaller one matched every fluctuation in the larger object's speed and orientation, like a tethered module being guided back into place. The Parker Solar Probe's magnetometers soon picked up faint harmonic signals between them, tiny magnetic fluctuations alternating at regular intervals. Each fluctuation from one object was followed by a mirrored response from the other, separated by exactly 2.3 seconds. Back and forth, a conversation in field lines. This was no random coincidence. In physics, synchronized magnetic oscillations across vast distances imply coupling, feedback between systems. That kind of resonance doesn't emerge by chance. It requires tuning. Whatever these two objects were, they were tuned to each other. NASA's analysis team quietly began modeling them as a single system, a primary and secondary. The smaller one, according to mass estimates, was about 1/8 the size of 3Den'i Atlas with a density roughly 3 times higher. It was heavier for its volume, suggesting metal Zen-rich composition. And yet it emitted no detectable heat. It was inert, but only on the surface. Inside the signal noise, a pattern emerged. Every time the two bodies aligned perfectly, their trajectories overlapping for a brief instant. Parker's sensors recorded a faint surge in low-gen frequency radiation, peaking at 5.3 Hz, the same frequency that had haunted the data since the nickel echo. The beat had returned. To most of the scientists, it felt like déjà vu, the same rhythm resurfacing now as a bridge between two separate entities. The smaller object wasn't just following the larger one, it was synchronizing with it, communicating through the same frequency that had once pulsed through the radio silence, the light flashes, and the magnetic field. It wasn't a fragment, it was a part. The prevailing theory inside closed gen-door meetings was that 3Den'i Atlas had divided intentionally, not from stress, but by design. The smaller piece, perhaps a module, had detached during the 40-3 minute gap, performed an operational release, and was now returning to rejoin its host. The implications were terrifyingly simple. If this separation was deliberate, then 3Den'i Atlas wasn't a single body. It was a system, a complex assembly of at least two interdependent components capable of operating independently and reuniting afterward. A vehicle, not a rock. The hypothesis was so explosive that it was never written down. It lived only in whispers among mission staff, in encrypted voice calls and off-Jan record memos. But the data spoke louder than caution. The smaller body's approach vector was linear, its deceleration perfectly timed to match the main object's speed. There was no drift, no random motion, and then at 20:10:6 UTC on November 3rd, it happened. The two objects converged. The contact event was subtle. No explosion, no plume, no light burst. Just a gentle merge. The radar signatures overlapped, becoming one. The brightness increased by exactly 11%. Not a flare, just a quiet adjustment. The smaller trace vanished into the larger, absorbed seamlessly. Parker's magnetometers recorded a single spike at that moment. A clean, perfect pulse lasting 1/10th of a second, followed by complete silence. Afterward, the entire system stabilized again. The rotation stopped changing. The shield retracted further. The field flattened. The signals ended. 3Zenai Atlas had gone dormant, but one final line of data from the solar orbiter refused to fit that narrative. In the seconds following the ReadZen entry, a narrowband radio transmission appeared, centered at 8.41 GHz, an unusual frequency, far higher than any previously observed from the object. It lasted less than 4 seconds. The signal wasn't broad-Zan spectrum, it was focused, beam-Zan-like, and its source direction was precise, outward away from the sun. For those 4 seconds, the object transmitted something. The signal didn't contain voice or binary data, but its carrier wave carried modulation, a repeating pulse train of 440 Hz, the same tone that ended the data gap, a tone emitted deliberately aimed into interstellar space. After that, the transmission ended. 3Zenai Atlas dimmed further, its reflective properties dropping below most detection thresholds. The plasma cavity collapsed completely, and the object began its slow drift out of the inner solar system, silent, steady, unresponsive. It was as if it had completed its purpose. The last line of the official ESA report summarized the event in language stripped of emotion, but heavy with implication. Object's trajectory remains consistent with hyperbolic escape. Active phase terminated following ReadZen entry convergence. In plainer words, it had finished whatever it came to do. The smaller body was gone, the field was gone, and 3Zenai Atlas was leaving colder, darker, and quieter than before. But as the object drifted beyond the range of most solar observatories, one final anomaly appeared, faint, distant, almost lost in noise. A second trajectory, barely visible, trailing it by millions of kilometers, moving slower, but following the same path, a residual echo. Whatever had been released during the 40-3 minute gap wasn't entirely gone. Something remained, and by the time telescopes realigned to confirm it, the trace had already crossed the ecliptic plane, heading outward toward deep space. By the morning of November 4th, the world's major observatories had data, but no agreement. Everyone had seen the same chain of events. The shielding bubble, the data gap, the ReadZen entry, the final pulse. And yet, no two agencies described it the same way. What should have been a unified report fractured instantly into politics, secrecy, and damage control. For NASA, the line was simple. 3Zenai Atlas was natural, a fragmenting interstellar body with an unusual metallic composition. Nothing more. Their press release, drafted in under 3 hours, called the 40-3 minute void a telemetry outage, and the ReadZen entry signal a non-Zan coherent transmission artifact. In other words, a glitch. ESA took a different tone. Their internal bulletin used phrases that were neither affirming nor denying. Words like non-Zan gravitational acceleration and reflective modulation filled paragraphs that said little but implied everything. One analyst joked bitterly, "We've invented a new dialect. Bureaucratic for impossible." China, meanwhile, stayed silent. The Chang'e data was locked, access restricted even to allied researchers. The only acknowledgement came in a single line added to the official mission log: thermal data under ReadZen evaluation, Perihelion event classification pending. But by then, independent astronomers had already begun publishing their own reconstructions drawn from whatever fragments of data survived the lockdown, and their findings told a very different story. Those reconstructions showed precision, spin alignment, trajectory correction, the 20-8 minute pulse, and finally the controlled deceleration. To the independent networks, the evidence was clear. Too many synchronized systems, too many repeating cycles. One group, the Celestia Research Collective, released a 200-page document titled "The Case Against Coincidence." Their conclusion was blunt. 3-Zan I Atlas executed a multi-Zan phase operation at Perihelion consistent with controlled field deployment, energy absorption, internal reconfiguration, and reassembly. The event sequence is statistically incompatible with random natural processes. The paper spread online within hours, even before the servers hosting it went dark. Its diagrams showing the object's synchronized frequency bands, the matching harmonics, the nickel-Zen carbon chemistry circulated on forums and encrypted chat rooms. People gave the object new names: the architect, the vessel, the mirror. But the deeper the public looked, the faster the data vanished. Videos disappeared. Archive links broke. Datasets went offline. Even cached files failed to load. Some saw that as proof of suppression. Others saw it as evidence of chaos. Too many amateurs amplifying noise. Too many conspiracies clogging the signal. Within days, the argument hardened into two camps: the naturalists and the interventionists. The naturalists, the official line, argued that everything about 3-Zan I Atlas could still be explained by extreme, but natural physics. They pointed to the object's interstellar origin, its retrograde path, its violent perihelion heat. They argued that metallic sublimation, magnetic instabilities, and complex thermal gradients could mimic the appearance of control. To them, the 40-Zan 3-Zan minute gap was an artifact of sensor overload. The re-Zan entry, a simple fragment recombining due to gravitational cohesion. The 8.41 GHz pulse, a coincidence caused by cosmic background interference. The interventionists saw none of that as coincidence. They mapped the timeline, the missing frame, the jet alignment, the silent band, the inverted polarization, the nickel echo, the shielding, the 40-Zan 3-Zan minute void, the re-Zan entry, and saw choreography, a controlled, deliberate sequence, a script, not an accident. One section of their leaked draft summarized it with terrifying clarity. Each anomaly fulfills a function: ignition, propulsion, concealment, deceleration, reassembly. This is not random, it is procedure. But even among interventionists there was disagreement. Some believed 3-Zan I Atlas was a probe, autonomous, ancient, triggered by solar proximity. Others thought it was a seed, self-gen replicating, harvesting energy, waiting. And a smaller, more radical group believed it was communication, not a vehicle, but a message, a signal that had to become physical in order to be heard. Inside official circles, none of these ideas could be acknowledged. The language stayed cautious, but the tone changed. The classified ESA summary for the European Parliament used phrasing that was technically accurate yet deeply suggestive. Current data indicates that Object 3-Zan I Atlas exhibits an organized response to solar proximity and external energy input. Classification remains undetermined pending further trajectory analysis. An organized response. It was the closest any government agency came to admitting that something deliberate had taken place. Then in late November, a quiet event confirmed the split. The US Naval Research Laboratory stopped sharing solar data publicly, indefinite maintenance. A week later, China's infrared observatory at Kunlun went dark. ESA's open telemetry portal returned only a blank page. The public data era of 3-Zan I Atlas was over. From that point forward, the story existed in fragments, data leaks, intercepted emails, anonymous testimonies. A NASA contractor claiming to have seen a secondary beacon. An ESA scientist who described a directional residual trace extending beyond Jupiter's orbit. A Chang'e technician who swore that the deleted thermal frame showed a lattice, not a triangle. But in all of those accounts, one phrase appeared again and again: it didn't leave alone. That phrase wasn't metaphor. 2 weeks after the object vanished beyond the sun's glare, a new anomaly appeared in deep space tracking data, weaker, smaller, colder, but following the same outbound trajectory. It wasn't a comet, not an asteroid, not a known satellite. It reflected faintly, irregularly, as though composed of fragments. But its velocity was identical to 3-Zan I Atlas's escape speed. The official statement called it a trailing dust aggregate. Independent researchers called it the remnant. The debate that followed became more than scientific. It was existential. If the remnant was natural, then 3-Zan I Atlas had merely fractured, an inert rock gone forever. But if it wasn't, then something had been deployed. Something now drifting, beyond the reach of any probe or telescope, carrying with it whatever purpose the Perihelion event had served. By December, one final dataset arrived from the Parker Solar Probe. Fragments of telemetry recorded weeks earlier, corrupted but partially reconstructible. When decoded, the magnetometer data showed faint ripples repeating in the solar wind spaced evenly apart. The frequency 5.3 Hz, the same heartbeat that had followed 3Ni Atlas since the beginning. The signal wasn't coming from the object anymore. It was coming from its wake, from the corridor of space it had passed through. The rhythm had embedded itself into the solar plasma like an echo that refused to die. And in that moment, a disturbing possibility crystallized among those still following the data. Maybe 3Ni Atlas hadn't come to deliver anything. Maybe it had come to leave something behind. Whatever it wasn't visible now, but every model agreed on one detail. The object's vector had changed again, subtly, silently, pointing not directly outward, but slightly above the ecliptic. Its new heading aimed toward a region of interstellar space near the constellation Lyra, the same region where Oumuamua had come from 8 years earlier. No one wanted to write that down, but everyone noticed by early December most of the world had moved on. The public had grown weary of speculation. The media had replaced mystery with politics, and the official narrative that 3Ni Atlas was a disintegrating interstellar comet had settled into accepted fact. But inside mission control rooms where the real telemetry lived, nobody was convinced. Something about the data refused to make sense. The outbound object, faint, cold, fading, wasn't fading fast enough. Even at its distance from the sun, its albedo remained unnaturally stable. A comet this far out should have dimmed exponentially as reflected light dispersed, but 3Ni Atlas's brightness curve flattened. It wasn't decaying, it was maintaining. Some invisible mechanism was compensating for energy loss, keeping the light steady even as solar power diminished. That constancy implied one thing, an internal source. When Parker Solar Probe's last data packet was decoded, it contained an anomaly buried so deep it took 2 weeks to find. A residual magnetic fluctuation, subtle but periodic, repeating every 3 hours exactly. The object's rotational period. The spin was generating a magnetic rhythm, faint but organized, and inside that rhythm, something else appeared. A secondary beat delayed by precisely 0.12 seconds, as if two synchronized components were still operating within. That double pattern revived a theory most agencies had quietly buried, the dual-core hypothesis. The idea had first emerged weeks earlier when radar modeling suggested the interior density didn't match surface mass. The outer layer, the reflective shell that produced the strange polarization, accounted for less than half the object's gravitational signature. There was something denser inside, offset from the center, orbiting within the structure like a gyroscope. At the time, it was dismissed as mathematical noise, but the new magnetic data made it real again. If the external body had a hollow cavity and the inner mass was moving, the two could interact magnetically, generating the very oscillations Parker detected. In other words, the object wasn't solid, it was layered. That revelation reignited the old argument. Was the core simply dense material trapped inside, or was it something else, something designed to move independently? ESA's internal physics team modeled the scenario. Their simulation showed that if a central mass rotated within a hollow shell, the resulting torque could account for every anomalous motion 3Ni Atlas had exhibited, the spin acceleration, the self-gen correction, even the shielding field. The system functioned like a reaction wheel, a stabilization device used in spacecraft to control orientation without expelling mass. That parallel terrified everyone who understood it because it meant the object wasn't behaving like a spacecraft. It was one, at least in principle, a self-gen regulating, gyrodent stabilized body capable of field manipulation, chemical regulation, and directional control. A machine that used physics itself as its fuel. The realization spread in whispers, not memos too dangerous to print, too undeniable to ignore. The key evidence came from the final infrared scans. The last time the object was still close enough to detect thermal variance. Within those readings, analysts found something no natural comet could produce. A heat pattern that repeated in symmetry across opposite hemispheres. Not random patches or sunlit zones, but paired hotspots moving in perfect mirror alignment. The heat wasn't leaking outward, it was circulating. A closed loop. That circulation matched the frequency of the object's rotational period, suggesting an internal system redistributing energy like convection, but mechanical. It kept temperature uniform across the surface, even as external radiation dropped. The phrase that appeared in the ESA data commentary was carefully chosen: thermal equalization consistent with internal energy management. No one could bring themselves to write the word reactor, but that is what the data implied. Not fission, not fusion, but some form of continuous energy balance. NASA's Ames Research Center quietly ran a reverse modeling algorithm to test that possibility. If the core produced electromagnetic energy at a specific frequency, how strong would it need to be to maintain the observed equilibrium? The answer was unsettlingly small, a power output equivalent to a few megawatts, tiny by human standards, but sufficient to stabilize the shield and maintain internal function indefinitely. Indefinitely. That word lingered in every conversation. If the object could maintain itself without decay, then 3Dni Atlas wasn't just stable, it was persistent. And that led to a darker question. What if the object wasn't new? What if it had been here before? One data analyst at the Harvard and Smithsonian Center for Astrophysics noticed something strange in archival solar records. In 1970 Gen 1, the Helios Iuni Eshon, one of the earlier solar probes, recorded a transient reflection near the Sun's limb with similar polarization behavior. The report was forgotten, dismissed as an artifact, but the coordinates matched the same orbital inclination as 3Dni Atlas's current path. If the orbits were extrapolated backward, they intersected right where the reflection had been. It was as if the object, or one just like it, had passed this way before. The pattern repeated in older data. A faint anomaly recorded by Skylab in 1970 Gen 3, another by SOHO in 1990 Gen 8. Each time a small reflective body appeared briefly near the Sun, vanished behind glare and never returned, or so it seemed. Now, the possibility no one wanted to say aloud took shape. 3Dni Atlas might not be a visitor at all. It might be a return. If so, it wasn't random that it arrived in 2020 Gen 5, it was scheduled. That idea that the object had been here before, that its trajectory was cyclic, spread through internal circles like a rumor too dangerous to believe. The orbital math supported it, with its current velocity and direction. If it had departed the solar system previously, it could have looped through interstellar space and returned decades later on a mirrored path. The odds were microscopic unless the trajectory had been chosen. The question that haunted the next week wasn't what is it, but why now? NASA's trajectory models predicted that 3Dni Atlas would cross the orbit of Mars by mid-December before fading beyond the reach of current instruments. But when analysts projected its path forward, they found a subtle anomaly, a deceleration curve that didn't match gravitational expectations. It was slowing down again, not dramatically, but measurably, like a body preparing for capture. The deceleration aligned with a narrow vector intersecting the orbital plane of Earth, not directly, but tangentially, grazing the region where Earth would be 6 months later. When this was reported internally, no one reacted immediately. Then one engineer quietly muttered, "It is not leaving." The room fell silent. The phrase caught on across teams, half joke, half warning. It is not leaving because nothing else fit the data. 3Dni Atlas wasn't accelerating out of the solar system. It was adjusting, curving, regulating its speed as if waiting for alignment. By that point, all agencies had sealed their data, and no further public updates were issued. But one last leak escaped, an internal ESA simulation slide that briefly appeared on an unsecured server before being taken down. It showed a cross-gen section of the object reconstructed from density data, a hollow outer shell, a dense rotating inner mass, and between them an empty void perfectly spherical. The caption beneath read only, "Core Stabilization Chamber, Unknown Purpose." That was the last official reference to 3Dni Atlas ever published. After that, it disappeared completely from observation. No light, no heat, no trace in radio or magnetics. It was simply gone, but space doesn't forget. In the weeks that followed, subtle disturbances appeared along its projected path. Minute ripples in the solar wind, shifting in the same 5.3 Hz rhythm that had followed it since arrival. Not a signal anymore, but an imprint like a heartbeat left in the fabric of space. Scientists called it residual noise. Others called it something else, a pulse, a reminder that somewhere out there in the cold, a hollow object with a hidden core was still moving slowly, deliberately in silence. And maybe, just maybe, it wasn't finished. Video introduction. It is November the 2nd, 2020 Gen 5. For weeks, telescopes around the world have been waiting for this. The precise moment when 3Dni Atlas skimmed past the Sun, reaching Perihelion. The point of closest approach. The point where everything that had been hidden behind brightness and distance would finally be revealed. But when the data came in, something didn't add up. Observers expected a classic thermal outburst. Gas jets flaring, volatile ices boiling off in the heat. Instead, the first frames from the Solar and Heliospheric Observatory showed something else. A sharp directional flash like a reflection rather than a burn. Then 1 frame later, nothing, a missing image. And when the feed resumed, 3Denai Atlas was already moving away from the sun, slightly off its expected trajectory. At first it looked like a routine glitch. Every mission loses frames under solar glare, but this wasn't any frame. This was the moment of perihelion itself, the single instant when the object should have been brightest, hottest, and most visible. That was the image missing, and what followed was even stranger. Temperature readings from multiple instruments, the Parker Solar Probe, the Solar Orbiter, and several ground-based observatories, all showed a spike, not just heat from sublimating ice, but something far higher, something reflecting energy rather than absorbing it. For a few seconds, the object acted less like rock and gas and more like polished metal. Across observatories, radio astronomers reported interference, a brief blackout that aligned exactly with the missing frame. At the same moment, polarization data from remote sensors in Hawaii recorded a negative shift, unlike anything seen in natural comets. Something happened at perihelion, something the sensors caught and then somehow lost. The question now isn't just what we saw, it is what was exposed, because if these readings hold, then 3Denai Atlas didn't simply survive its solar pass. It revealed something about itself, something that no known natural body should possess. And that is where this story begins, with one missing frame and the mystery it left behind. Video conclusion. Weeks passed. The last confirmed detection of 3Denai Atlas came from a deep space array in Chile on December 17, 2020 Den 5. A faint point drifting against the background of Taurus, too cold to register thermally, yet still somehow rhythmic. The instruments caught a final pulse at 5.3 Hz before it disappeared completely beyond their range. After that, the data flatlined, but the absence didn't feel like an ending. It felt like the closing of a door. Every theory that tried to explain the object, comet, relic, probe, collapsed under its own contradictions. Its behavior was too ordered to be natural, too restrained to be mechanical. It performed a sequence and then erased itself from observation, as if aware of being watched. What it left behind wasn't debris or radiation. It left patterns, harmonics folded into the solar wind, low-gen frequency pulses echoing across plasma sheets, whispers that no one could trace back to a source. The official record calls them residual magnetic fluctuations. The engineers who first saw them gave them another name, the Atlas tone, a vibration that seemed to hum through the data itself, faint but persistent, as though the instruments remembered what they had witnessed even after the sky forgot. In the weeks that followed, the agencies stopped arguing. Reports were sealed, teams reassigned, instruments recalibrated to other targets. Yet inside every dataset, hidden under layers of clean, silent telemetry, the pulse continued, a barely measurable quiver that surfaced every few hours, repeating with the same mathematical precision as before. Perhaps it was nothing, or perhaps it was nothing, or perhaps it was what the object wanted to leave behind, a trace of rhythm, an imprint of its presence, like the echo of a machine that once synchronized itself to the sun and then vanished into the dark. Somewhere beyond the heliopause, 3Denai Atlas keeps moving, coasting through silence. If it ever changes course again, no one will see it. But every so often, in the static of solar wind recordings, the same frequency returns, steady, indifferent, unbroken. The signal beneath the noise. It is all that remains.